astTECS, leading enterprise telecom brand.
And then start with my small presentation. Okay, is my screen is visible?
Yes, Dhanapati, please
Yeah,
proceed.
yeah. So, so when we call as security applications, generally we always think antivirus and firewall. So a few things that both does same job, means antivirus or firewall, any one we need. Okay, so basically this concept itself it's a wrong, like a firewall and then antivirus, it is not a same product, it is a completely two different application. Okay, so what firewall will do is it's a protect the in local network, and it's actually it's bridge the local network and the public network. Okay, and it checks only the traffic flow between local internet and then local to the internet connection. Okay, but antivirus will not detect any of this. Okay, so it checks only the system activity, the application which runs on a system. It monitors, and then based on the activity, it just blocks the application, or it's uh, um, alert users. Okay, basically antivirus is only the software application. Okay, so we just buy the antivirus and install in any running system. Okay, firewall is both. Okay, so we have software firewall also, and then a hardware firewall. So software is a individual user can install it in their system, and for additional security other than antivirus, they can install firewall also in an individual system, and then they can allow the port wise traffic. And hardware based is basically it's for the enterprise, where we have the internet connection, and behind the firewall we have a set of users. They use multiple applications through internet. Okay, so I just see last webinar, few was asking why when we implement this firewall, do we need antivirus also? That's why I added this slide. So it is antivirus and then firewall. It's not the same, and it's two different applications. Okay. Now, so what is firewall? As I said, the firewall it sits between the internal network and then public internet. Okay, so based on the enterprise or organization's security policies, it allows the traffic in and out. Okay, so main purpose of the firewall is to allow the non-threatening traffic in and to keep the dangerous traffic outside. Okay, and firewall is nowadays it's considered as the essential component of the network security. So any network we deploy, and firewall is a very essential component now. Okay, and so what is the importance of the firewall? It just some history about. See, firewall is there from 1980s with only the IP filtering packets. Okay, so it is how the firewall are more important because they had the huge influence on modern security techniques, and are still widely used. As much of the business world goes into digital, it is that imperative that forward-thinking companies focus on securing their system from external threats. Okay, so means when we deploy, or when we give any service, any product, any support. Okay, so it nowadays it's all interconnected. It is connected to the network, internet. Okay, so we deploy anything which connects to the internet, we should have the firewall. Without firewall, it's too risky to deploy any system to the public network. Okay, so without firewall, we may not be able to control the outside communication or the access or traffic coming to our system. Okay, So firewall, it will first it takes all the traffic and then it analyze it, and then if the packet is we have the route, means we set from these destination we can allow the traffic, or if the user requests these type of access, then firewall will forward it. Otherwise it just blocks these unknown or anonymous requests coming from the internet. Okay, so there are many type of firewall available. Okay, so these are like, it is not mandatory, or it is like versioning. Okay, so first generation of the firewall is only packet filtering. Okay, so they used to set port based access. Okay, so if we have a static IP, and then it is open to anyone, okay, from the network internet. So initial stage what they used to do is they set the port wise, means we want to allow a remote desktop, or you want to allow only the web access, or you want to allow the SSH access. Okay, so whatever service we are using, or whatever service we are using, also the well known or the trusted IP address. Okay, so they set it in the filtering, so only those traffic will happen. Okay, and still uh, so when technology moves on. Okay, so only the packet filtering is not helpful. Okay, so and then next stage comes in where they have implemented with the circuit level. Circuit level is like further more step, like when we have traffic goes from internet to our local network. Okay, so it is not only the packet we allow. Okay, so assume we allow the web service. Okay, and then we allow the web service and SSH or the desktop. Okay, remote desktop we are allowing it. And nowadays the hackers or the anonymous traffic is improved their um, techniques to access the remote site. Okay, so what they do is they come as a proper channel, a proper port and source, or source and destination address, but still um, they just try to see, assume like now I'm opening yahoo.com, and then I'm searching some data. Okay, so assume I'm searching for IPPBX. Okay, and then it's like when I click on IPPBX related data, from my system connection goes out to the Yahoo, and then it comes back. Okay, so when it sends back data, and then hackers, what they do is they just send anonymous along with this request. Okay, so I requested to one service, as in Yahoo is responding or Google is responding to my request, and along with that a few more requests also will come into the system. Okay, so with the packet filtering, it will not detect these type of traffic. Okay, so circuit level, what it will do is it just check, is there any request, any active connection to the active session to this request. Okay, so it's like I requested something on a Google page, and then Google is sending back me some data, and along with the Google request, few more request also comes in. Okay, so the circuit level firewall, what it will do is it just checks the active connection, is there any request from the user side to this server, and from where we are getting the traffic. Okay, and then it checks only Google. I requested to Google, and then it allows the Google's response to that session, and then remaining whatever data anonymous session request, it will block it. Okay, so it's more secure. It's like next step to the packet filtering. Okay, and then third type of third one is a stateful inspection firewall. This is like both, it's combined together. So packet filtering and then circuit level combined together works as a stateful inspection. it does the same like monitoring the active sessions. Means I open google.com and then keep browsing some data, so it keeps the user's connection, and then it monitors the communication between my PC and then Google. Okay, so now they have firewall keeps the table where it matches okay, the I requested and then Google serves my request, and same way we may have some 10 20 of people does the same job. Okay, so firewall will keep all these concurrent connections detail, and then it matches the in and out traffic, uh, and then if any anonymous or the packet comes from the unknown site or not from the Google, but act like a Google response. Okay, so this firewall will block those packets. Okay, so user will not receive those data. Okay, and fourth is a proxy firewall. What it will do is, see now I'm accessing Google from my browser. Okay, so Google can get my browser information like what is my browser version, what is my system, what is the system I'm using it, what is the IP address of it. Okay, so Google can get complete detail using this browser request itself. Okay, so like this so many applications are there, and the when we request from the remote side they can get uh, more information about the user's detail. Okay, not only the user account, they can get the system information also. Okay, so proxy based firewall, what it will do is when we send a request, okay, so it never sends users information to the Google or the outside. It will act like a proxy. We send a request to firewall, and firewall will request to the Google. So Google will not get further information like from which browser, what is the IP address, and what is the OS they're using it. So these information will be blocked from the firewall itself. Only the remote server gets only the request from firewall, and then it will get the information about the firewall. Means the basic information. Firewall is not going to reveal the firewall's its own identity. Okay, it just act like one user in between the actual user and then the remote server. Okay, and next gen firewall is, it's kind of a like it, it has everything. Okay, so it has a packet filtering, and then a circuit level, and then proxy, and also whatever is not available. Okay, so they give an option, you can download it from the their like marketplace. Okay, so like Google Play Store. Okay, so all the firewall, what they do is whatever is not available default, or there is an alternate. Okay, so like I use one application to filter email. Okay, so now I feel like this is outdated, or it's not getting any security patches. Okay, so I want to use a another mail filter or for my firewall. That is possible. I can disable the one, and then I can install the other one. In this there is a lot more applications available, and also we get the like a community shared applications, and also a few commercial modules also available with this firewall. So when you see any firewall with this type of module, means all the module along with the provision to download the third party applications. Okay, and it is generally called the next gen firewall. Okay, these are the five types. Means it's not kind of a five types, it's like a generation. Okay, first it started with the packet filtering, and then circuit level, and then state level, stateful inspection, and then proxy, and then the modern or the current one is called as a next gen firewall. Okay, and uh, now we have selected the OpenSense as our firewall application. Okay, as you all know that we work on only on open source based applications. Okay, and out of all the available open source firewall, we found this works better, and then it has very clean application. Means there is no much confusions or installation and then maintenance is very user friendly. Okay, so that's why we have selected the OpenSense firewall, and it is a BSD based application. Okay, so and also name it says it like name is derived from the open and then sense. So together it's like open source makes sense. Okay, so we also like this type of application. Okay, so that's why we selected the OpenSense as our firewall application. And core feature about the OpenSense is it has almost all the major firewall features. Okay, I'm just sharing only the core few of the core features. Okay, traffic shaper is there, and captive portal. Captive portal is see it's like now we deploy our firewall in a bus stand or a railway station or some place where many people will uh, co- come and go. Okay, so now so see nowadays there are few service provider. You go to the railway station or any bus station, they have a Wi-Fi, and when you connect for a few minutes, you get a free internet, and after that you have to do a recharge. Once you do the recharge, and then you can come in continue the internet access for a few sometimes. Okay, so we can implement using this captive portal. So this is a separate module. Okay, so using this we can generate the voucher, and then we can give this voucher to the subscriber who wants to use it for a temporary purpose. Okay, so it is like a prepaid internet service. And forwarding caching proxy is a same web browser, a web proxy. Okay, and VPN, it comes with a IPsec tunnel, and then open VPN client, open VPN server itself. Okay, and high availability and then hardware failover. So it even has the high availability feature and hardware failover. So we can have a we can set up the primary and secondary. If primary goes down and then secondary, it will switch over automatically. Okay, and built-in reports and then monitoring tools. So this is a very important feature. See, all the firewall provides the reports and monitoring tools. Okay, so but uh, no, they provide most of the time they provide only current activity. Okay, so they don't store the log. If you want to store the log historical data, you have to get a separate license. On top, you have to store that in a separate system, not in the same system. Okay, so with OpenSense, it has everything in. Okay, means we no need to buy any license, or we no need to um, integrate with or communicate with other hardware to store the logs. Okay, and support for plugins, as I said, as a next gen firewall, it has so many plugins we can download and install in on the go. Okay, and it has a backup and restore option. When we make any changes, we are not sure this will work fine, or it may create some disturbance in the ongoing traffic. We can just we can take the backup and then do the changes. If works fine, we can leave it. If there is any trouble, we can anyway restore the backup. Okay, so these are the key core features of OpenSense firewall. Okay, so now I will connect to my firewall, and then I'll explain you the how we can configure it. Okay. Okay, this is a OpenSense. firewall dashboard. Okay, so it shows the system information and CPU usage, memory usage, and then network usage. Okay, and in the bottom, see, it is like whenever we add the services and modules. Okay, so this page gets expanded, and then so it dynamically adjusts the data here. Okay, so we have here we have the four interface. Okay, so we have the ACT1 and 2. These are two internet connection we have, and then one LAN, and then one more connection we have set it for a Wi-Fi network. Okay. Okay, so now moving to the use cases. So see, now assume we have the small office. Okay, so we want to set up internet, and we have some 10-15 users. Okay, so how can we configure it for 10-15 users? Okay, so first what we need is we need a internet connection, and then once we connect the internet, and then we share this internet to the local users. Okay, so for that first we have to set up internet connection generally. So in assignment we can see interfaces. It's a network interface. Okay, so in a network interface we have here you can see whatever ethernet LAN port we have, it displays here. Okay, so here we have 5 ethernet interface. Okay, so first one we okay, so now type of connection. So type of internet connection is like now Airtel provides with a modem. Okay, so their user ID password is stored in the modem itself, and then modem, from the modem we take the out, and then we connect it to the firewall. Okay, so in that case we get only the IP address and not the username and password. But when you have the ACT, uh, like ACT, you have a like ACT account. So they generally they give optional, means a modem is optional. It is like a PPOA connection. You have to give the user ID and password when you connect, and thereafter you can browse the internet. Okay, so so those type of connection is called PPOE. And then assume you have Airtel gives a modem. From the modem we take a connection. That is we can set it as a static IP address or a DHCP IP address we can configure. Okay, so now here we already configured. I'll just show you one example of connecting ACT. Okay, so we have to enable the interface first, and then we here in the IP configuration we can set static IP or DHCP. In case we connect the PPOE, we just set it PPOE, and then remaining things we know it. It's not that all the column we have to fill it. Okay, I'll just explain the very basic information. What are the mandatory fields we have to fill it? Okay, so this is the ACT account, and then password, and then submit. So if the line is proper, and automatically it will register, and in the dashboard we can see ACT is connected and up. The connectivity is there, and then it is up. Okay, so in case we set, okay, we want to set as a, now we have Airtel internet. They have terminated the internet in modem, and we want to set we want to connect the firewall to the Airtel modem. Okay, so in that case we can set it as a DHCP, and then connect the cable from the modem to this port 1. Okay, so here we have set it as a ACT interface itself. We set it as ACT1. You just connect it to the port, and then system will get the IP address, and then it start accessing internet from the Airtel modem to the firewall. Okay, so assume we have configured internet. Okay, so here we set the internet connectivity details. Okay, so now it's about the local area network. So uh, from the user, how they can access the internet, or how we can configure their system IP address. Okay, so here I created one more interface LAN, and then I'm setting as a static IP, and then this is my firewall local LAN IP address. Okay, 001, and then I set it into subnet 8. Okay, so now I set this firewall into local IP address, and so now we have set the internet, and then I have set the LAN IP address to this firewall, and how the users can access it. Okay, so now we have set the firewall ready, and when we connect a laptop or a desktop, how they will get a internet. To receive IP address and then get the internet, we have to configure the DHCP service. Okay, so in the services, we have a DHCP. So we can assign, see, now I'll explain a little more, like in the interface we have internet connection, and then we have a LAN. Okay, so now we want to configure Wi-Fi in a separate network, not into the same LAN. Okay, assume we want to have some restriction for Wi-Fi users. We don't want to give them a complete internet access. We want to have some limited access for Wi-Fi, and then LAN users can have a complete access. So we can do this type of connectivity using the interface. Okay, so we set a LAN on a specific IP address, and then we set another interface only for a Wi-Fi connectivity. Okay, and then when we configure this interface and then IP address. Okay, for this user, Wi-Fi users, we have to assign IP address, and then we have to allow them to use the internet. And LAN users also, we have to allow them to means we have to assign them IP address, and then we have to set their rights to access the internet. Okay, so that we have to do it from services. Click on service. We have the as I said, the captive portal. Here we are not using the captive portal, but we can set, we can create the voucher, and then we can activate this service. Okay, uh, in a DHCP, where we are going to assign, means for LAN users, we are going to create a DHCP service. Okay, so we are saying range from 8.12 and 254. So this range we can keep. Uh, there is no restriction. Okay, we can give any range here. Okay, and then we define the DHCP and then gateway to this DHCP service. And also we can assign few more data, like okay, see, now earlier we in PBX IPPBX webinar, we have explained about um, uh, auto provisioning. Okay, so to configure auto provisioning, DHCP server has to provide the IP phones from where it has to download the settings. Okay, so those type of information, not only giving IP address to the users, we can give few more information to the user's desktop or the IP device, whatever we are connecting. Okay, so to connect or to provide information, we can set a TFTP server. This is what we use it generally. Okay, so we do have a TFTP server, and we have set it here. And then when we save it, okay, from next minute, the firewall start providing the DHCP services to the users. Okay, when we connect the desktop or a laptop to the network, our system will automatically get the IP address from this service, and we can see how many device registered, and what is their MAC ID and host name possibly. Okay, so this is a dynamically as and when they connect the system to the network, the DHCP service will provide them IP address, and then it stores the temporary table with their MAC ID for the routing purpose. Okay, and with the DHCP, a few more option is there, like even we can set, we know the MAC ID and we want to specify a fixed IP address. Those information also we can do it with a fixed leasing using this DHCP service. Okay, so now we have set the DHCP service, and we have set the internet connection, and users also, they received IP addresses. Okay, so when they open the browser, and then start searching, or they can start accessing the internet from their system. Okay, so now we have set up the basic need, like we configured the internet to the firewall, and then we have enabled the LAN interface, and for the LAN interface we have assigned the DHCP service. So when user connects their system, they receive the IP address, and then they can start accessing internet. Okay, so now it's a very plain, like internet modem we have set it, they can access the internet. Okay, so furthermore, settings. So to tune the incoming and outgoing traffic. Okay, so what we can do is so in the IP intrusion detection. Okay, so you can enable this service. Okay, so automatically this will monitor the user's activity. Okay, so when they access the data through internet, or anything they download it, so in and out traffic coming from the user side, firewall will monitor if it finds any uh, activity which is means abnormal activity, or the not the legitimate connectivity. Okay, so it will blocks those IP address, and then it will stop the connection to that IP address from the user to that IP address. Okay, and we have a few more options, like we can set the web proxy. Okay, so as I said, now all the users access the Google or any other search engine or any other web service. Okay, so when I access from my system, it is always they get my system information. Okay, so who's accessing, who's the user, from which server, system, and few information about the system, they get everything. Okay, so using the web proxy, we can enable this web proxy, and then the firewall will be the middleman. Okay, so whatever user request, okay, request goes to the firewall. From the firewall only request goes out. So the service provider, the content provider, they get the firewall information only, they don't get the end users detail. Okay, so using this we can control it. Also we can control few more data, like say now uh, um, since we it's office network, and we don't want the uh, employees to access the social media, or we want to allow them the time based connectivity. Okay, so in the productivity time, we don't want them to access the any social media. After the login hours they can access, or based on the user and password they can access. Like that also we can set it in the firewall, sorry, web proxy. So also we can set the whitelisting the domain, and blacklisting the domain. Assume some site is not good to watch, or it is malicious, and then it is give some like, yeah, means it's like it's not the good content to watch. Assume it's not a good content to watch, and we don't want them to misuse the office internet to access those site. Okay, so we can blacklist those site, and or we can whitelist a few site, and then we allow only the whitelist site will be accessible by the users. Okay, so these type of access will get it in the web proxy. Okay, so it has a, multiple type. Okay, so generally we use the transparent mode. It just act in between the user and then the content providing server. Okay, and on top we can access, we can set the user ID and password to access the internet, or to access some content which we filter it. So see, here we haven't activated any service, so we don't have any content here. Otherwise, we can see some service are there. We can just subscribe and then activate it. So periodically they update the sites. Okay, so not trustworthy sites, those information blacklisted IP address or domain names, it keeps updating, and then firewall will update those information, and then based on that traffic will flow out of the firewall. Okay, this is about the web proxy. So we configured the internet, and we have configured the users network, and then they are able to access the internet, and we have enabled the institution detection, and on top we have enabled the web proxy administration. Okay, so with web proxy we can control more of their users browsing content. Okay, so uh, is it clear, or is there any gap? You see,
Yeah, Dana, you can just proceed whatever the discussions or a doubt we will discuss in the question and answer sessions.
no, okay, okay. So see, okay, thank you. So these are the very basic, means we have the very small office and we want to configure the firewall, and these are the very needed thing, means to protect our network and then protect use the internet effectively. Okay, so and then I will move to the user case 2. Okay, use case 2 is assume we have the bigger office, and we have multiple services we are providing, multiple departments available, and then what are the things they will use it. Okay, so it is like a same setup. We configure internet, we configure the user LAN, and then Wi-Fi access. Okay, and then we provide the web proxy to filter the users. Okay, what more we can do for the medium office, or the uh, office with a more department, and then services they provide. Okay, so uh, for the medium enterprise, what we can offer is we can give them assume they provide services, multiple services, so they can control, or they can provide or host their service from their office using this firewall. It is about, I'm saying, assume even if it's for a demo purpose. Okay, so they can host their server inside their office, and then using the firewall they can share, or they can provide the demo to the user, instead of every time they have to use the cloud infrastructure. Okay, so they can use it, as I said, it's a medium office, so they can use it inside office. They can host the server and use the firewall, and then they can set all the um, protections, and then they can start using it for the demo purpose. Okay, and not only that, and nowadays it's a work from home is a work from home is there. Everyone is taking the work from home option. Okay, so for that also we have a option in our firewall. We can provide them VPN service. We can configure the IPsec or open VPN, and then users can use uh, this credentials, and then they can connect to the firewall. Once they connect to the firewall, and then they can access the internal office network. Okay, okay, so we again I'll explain little more about the interfaces. Okay, so as I said, LAN, and then Wi-Fi internet. Okay, so now what we do is we configured LAN users. We set one IP series for them, and any LAN user, they connect the desktop or a laptop, they get this IP range, and then they have we have set some rule for them. They can access internet. Okay, so for Wi-Fi users, we have set a different IP segment. Okay, it is in a different IP segment, and when I connect my mobile, okay, so I get this 192 range IP address, and whatever we have uh, policies, we set it on DHCP service Wi-Fi. We have set some range IP address for these users. Okay, so now they have connected to the network. They have connected to the firewall. Okay, so when user request, okay, so when one okay, so when uh, request from the LAN, okay, so we can control using the firewall. Okay, so here what I do is request from the users from laptop and desktop. When they try to access a remote site or any service, okay, I can create a separate rule for them. Okay, I'll give you some example. So interface, I'm selecting I'm giving a pass. Okay, we are just passing the traffic, and source is a LAN interface direction. From the LAN we are getting the request to the firewall, and destination is you select the uh, here we have the two internet access. We can select any primary ACT account I'm selecting, and then if I submit, okay, so any traffic from the LAN users to the ACT account, it will pass. Okay, if we want to mention any specific services, okay, or the requesting IP address or the protocol or the service we want to mention it also, we can specify it, and then we can allow the traffic. Okay, so if I submit, so from the LAN users, when they try to access, their request will be forwarded to the internet. Okay, and same way when for a Wi-Fi. Okay, so now Wi-Fi users, I want to restrict the usage. We can set any request from the Wi-Fi, and to the source we can here we can send it to the different internet provider, or even we can disable this traffic, or even we can say once we add this rule. Okay, so even we can set the priority. Okay, so I just take this LAN traffic, and then I'll show you. See here we have so many rules set here. Okay, uh, see floor wise we have added the policies. Okay, so um, based on the priority, so it is not only the rule set here, it is also has the priority, first priority, second priority. So based on the priority only, it takes the traffic. Okay, okay, and okay, so assume we have one more like we have Wi-Fi users, and then LAN users. And then we have the guest account. Okay, so we have the conference room, and then we in conference room we want to provide the very basic connectivity only to our internal network or the demo system what we have it. Okay, so that rule also we can set it like see as I take the example of Wi-Fi. So sorry, in rule Wi-Fi, so what I can do is any traffic from the Wi-Fi I can pass only to other interface, assume firewall, or sorry, here I can select the LAN address. So from a Wi-Fi you can send the request only to LAN. You can't access the internet. Okay, so this type of routing we can set it from the firewall routing rules, setting the rules. we can control the user's access privilege. Okay, it's about the guest and then Wi-Fi users connectivity, and now we'll move to the NATing. So we we configured the LAN users and then Wi-Fi users and possibly some guest account. Okay, so now we have a request like um, we have installed on a server and we have to provide the demo to the customers. Okay, so um, since it is inside our office and we can't take it outside, or we can put it in the direct static IP. Okay, so we have a firewall. Using the firewall NAT option, we can publish our service, which is there inside inside our network. We can use the firewall and use the NAT service, and then we can publish the service to the from the static IP. Okay, so in firewall NAT, we have the port forwarding and one to one, and then few more options are there. I'll take only the port forwarding here. Okay, so here what we can do is any request coming to our static IP, okay, through this ACT account one, okay, and I can specify is it a TCP connection or a UDP connection. Okay, see, assume if it's only the web, so we can set only the TCP, or we provide web and some other service. Okay, so we can keep or we are not sure about what are the services protocol we use it in our service. Okay, so you can keep a TCP and UDP, and we can set a single host. Now Azim, I have some okay, so there is one server I have installed, and this is the IP address, and any request coming to ACT is a static IP. It will forward it to this uh, IP address. Okay, so here we just make the routing only. Okay, so we haven't changed any service. Okay, so here we can even assign few more port also. See what are the service you want to provide now to this IP address. Okay, sorry. Okay, so now destination I have set this IP address, and source. So traffic to which port I want to allow. If I set HTTP, and whatever request comes from HTTP or a web service request comes from ACT static IP, it will get forwarded to this local IP address. Okay, and see, assume we don't want to directly forward a port 80. We want to have a different service. Okay, so port 80 is okay, not much complication. Assume we have the VoIP or a SIP account. Okay, we want to provide the customer SIP service. Okay, so and providing SIP service to the default port is always risky. Okay, so what we can do is if you want any custom port, we can add the custom port by saying 5063. So now when we here we have the SIP service itself. When we say SIP, and then we are forwarding all the SIP requests to this server, will work fine, but it is risky to expose our SIP service to the outside world. So what we can do is I'm running SIP server in 179 and I want to provide the service outside using a public IP instead of connecting through same default port. Okay, we can configure through, so I can set it like, so user has to set different port other than the default. Okay, they can't use a default, but they have to request 5063 instead of 5060. And then when they request, firewall will receive the request and then internally it will forward it to the correct port. Okay, so using NAT, we can even forward the request to a same port or a different port also. For the users, it is a means from outside our network. If they want to access the SIP service, they have to use the 5063, but when it reaches the server, it will be 5060 itself. Okay, so using this different port, we can secure our system, even providing a web service HTTP or HTTPS also. We see, instead of giving HTTP here, if I give HTTP and then forward this request to HTTP, it is just forward all the traffic to HTTP. Okay, so assume my static IP is like 10 dot, okay, 100.20.20. Just one example. I'm just saying this is my static IP. Yeah, I just open this one and then it opens the page directly. Okay, without any port change. Okay, I want to secure my system. I can uh, from the firewall, I can set source IP as a others, and I can say 8082. And then here I can forward it to the normal default port. Okay, when I set it like this, from the remote side they have to open 201. Okay, so when you open only IP address, they may not get the any service instead of 8082. So if they give 8082 and then open browser, this will get translated to our local server and then it will open the web page. Okay, so if we they provide any service, okay, so they can actually block their original port. Okay, exposing this default port to the internet. Okay, so they can have some other port. Okay, some not the default one. We can select some dummy port and then we can set the port to the port in firewall. Okay, so now users access 8082. It is not similar or it is not the default port of any service. Okay, but when it reaches the firewall, it is forwarding to the port 80. Okay, so this type of natting we can do it. Generally when we do natting, this type of natting only we have to do. That's a safe way to do it. Okay, not only this port 80, we can so there are a lot more service we can do the NAT. We can forward it from static IP to the local. Uh, Not only to the one system, we can do it to the multiple system. We have a one static IP and we can map this static IPs HTTP to the one server and SIP to the other server, or if you have any FTP service we are running, that is we can connect it to the different server. Okay, so one static IP we can run multiple services and multiple, we can map that into multiple servers also, internal servers. Okay, this is about the NAT. Okay, and we'll now we'll check about we'll check the packet filtering. Okay, Okay, packet filtering is a rules we set it here. Okay, so any request come from LAN. Okay, so we can control from the rules here. Okay, so this is how the packet filter works. Whatever port we are allowing, so here SNMP port we are allowed, and then based on the source IP and then destination IP, we can allow the any traffic. These are any port we are allowing. Only the here it's the destination we are allowing it. It is a source. This source we are allowing all the requests. Okay, like that we can even further define the individual port, and then you can allow the access, and then you can deny the access in the rules. Okay, and second point is a traffic shaper. Okay, so traffic shaper is now uh, we have assume we have the internet connection or a 50 Mbps internet connection. Okay, and we have 100 users, and these 100 users and 50 Mbps connection, it is not working, or it is like most of the time it is very slow, and then they are not able to access the remote server, or they are not able to upload some files or something like that. So it is like um, we have no rule to uh, s- uh, set the flow of the traffic between user to the firewall and firewall to the users. Okay, so we can use the packet shaper. Using this, what we can do is we can um, uh, prioritize the packet flowing through the firewall. Okay, so assume we have the video calling, or we have the Teams meeting happening all the time with the client, or we have the audio calls, or VoIP service we are running. Okay, so or we assume it is a small, we have the small call center, some 10-15 people are there, they make a call through VoIP, and we have other set of users, they use data entry, or any other content service that they provide. Okay, so all are in the internet. So now assume call center agent's bandwidth is used by the other team, or the some other users use watch YouTube or videos or something like that. Then most of the bandwidth is used for that, and then the call center agents who's taking calls, they may have a voice breakage, or even they may not be able to talk to the customer properly. They may have a hiccup in their call flow. Okay, so now we have a different set of users, and they have a different profile, they do a different task. Okay, so now we want to now high priority is a voice. Okay, so I want to say all my VoIP call, means calls through the firewall, it should get high priority. Okay, remaining things is a less priority. Okay, so we can set those type of things in traffic shaping. Okay, so first I have to create the pipe. Okay, so I just explained you already. We have a few pipe added here. See here, I'm saying 20 Mbps connection. Okay, so I say 20 Mbps upload. I'm just setting it, and then the other one is 20 Mbps download. I have created the pipe. Okay, after the pipe, we have to add into the queue. In queue, sorry, rules. We say two internet connection. So ACT one is the primary internet connection from any source. Okay, and destination is from ACT to local network. Okay, so I'm saying target is 20 Mbps download. So from ACT to anyone downloads any application or any package is downloading. Okay, it will not exceed 20 Mbps download. Okay, you can't use more than that. Okay, so when it's like total it is a total connection size we are giving it. Okay, so now assume we have 10 users and then they are downloading some packages. Altogether, they can use a 20 Mbps download limit for them. Okay, and then next is it's a reverse like upload. Okay, so uh, uh, to the ACT from this local users, okay, destination to any using the internet. When they try to upload any data, we have set here 20 Mbps upload limit, so they can't exceed this limit. Okay, so using this traffic shaper, we can set. So as I said, we have the voice. We can set the voice the higher bandwidth limit, and then remaining data, whatever left, the other users can use it. Whatever we have specified here will take the high priority, and then what we haven't mentioned it takes the least priority. Okay, so using this traffic shaping, we can control the high priority communication. And so assume we have the VoIP, we can set the high priority to the voice call, or we have the team meeting or any audio video conference we are running on. We can set those IP address detail, and then we can say the maximum bandwidth limit for that, and then only they may have the clear communication. Rest of the users will not get this high priority on the bandwidth allocation. Okay, so this is about the packet shaper. And IPS is one more service. Okay, intrusion detection is already I explained. We have to just enable it. This service will monitor the communication between the users and then remote server. If there is any abnormal activity, it just mark it and then it blocks this communication to that remote server. Okay, and about VPN service. Okay, so now we configured the internet, and then we have set the proxy for the users, and then we have enabled our local server to the through the static IP for the demo purpose using the different port. Okay, and also we have set up the traffic shaping using the traffic shaper. Okay, so we can using that we set the priority to the traffic, means based on the department or based on the application, we can set the priority. Okay, and now we'll talk about the VPN connection. So now we want to allow the users to work from home. Okay, so what we can do using this our OpenSense is we this IPsec is basically to connect between two offices. Okay, so here we have the static IP, and then other branch office we have a static IP. So it is very easy. Using the static IP, we can create the IPsec tunnel between these two locations, and then we can share the services between two office. Okay, in case it is a user and there is no static IP involved in this connection, so we can create the OpenVPN server. Okay, using the server, we create the um, credentials. Okay, I created a server. Now I create the one. Okay, so here I can create the VPN client. I can say work from home, and then we can set any available IP address. I see. It is a we can have a multiple option here. We can set a username and password for the connectivity, or only the uh, key TLS key based authentication we can use it. Okay, just say Dana. Okay, so now I have created one VPN client. Okay, so I can use this client using this user ID and password to using the static IP. I can use this. See, I can show you some. I do have OpenVPN client. Okay, so after installing, and we can set these type of a connected, and when I'm going out of the office network, I can use any one of this VPN credentials. Then I can connect this as the user ID password. If it connects, and then I can access all the office network or office services from my desktop itself. Okay, so we can create the VPN client, and then we can use the VPN client uh, when user is not, means when user wants to connect from home. Okay, using the VPN client, you can, using his credentials, you can connect. Okay. Okay, so this is about the Open VPN. Okay, and the other options, we have the one minute. Okay, see, one more service. We can use the dynamic DNS. Okay, so dynamic DNS is, assume we don't have a static IP. Okay, so uh, but we want to provide service from means assume we have some server inside our office, we want to host it, and we don't have a static IP, and assume there is some complication in getting a static IP. Okay, so still we want to host our service outside. Okay, so in that case, we can use the dynamic DNS. Okay, so uh, there is a service called Dyne DNS where we can register and then get user ID and password. Okay, so once we say set the user ID and password from the Dyne DNS here, and this firewall every time will update the internet IP address. Okay, so I don't have the static IP, but every time internet provides me one IP address. Okay, that will keep changing it. Okay, so every time it changes, so we don't have the static. Okay, so but still we do have the one internet IP address. It is mapped to our internet connection. Okay, so what this dynamic DNS will do is it register this user ID and password will send the information to the dyne DNS. This domain means, assume when I buy a account, it will be like dana dot dynedns.com. Okay, that's the domain name, and that domain name is mapped to this firewall. Okay, so we don't have any static IP, but still this dyne DNS service can provide the domain name. Okay, which will connect to the dyne DNS, and then it will forward it to our firewall. Okay, from firewall we can enable the NATing as usual. Okay, so this service is a dynamic DNS, and even if we don't have a static IP, we can get the dyne DNS account. We can configure it here, and using this service, we can do the port mapping. Uh, uh, yeah, port forwarding or NATing. We can do this. Okay, so these are the uh, services needed for small to medium size enterprise or organization. Okay, so using this we can implement their means complete their all their network security need. Okay, so that's about the presentation. Okay, so is there any, if you have any questions on the topic or any other doubt you have, you can ask me now.
Yeah, thank you, Dana, for taking us through on the firewall solutions about the features and functionality. We have a couple of questions coming up from the attendees, and the first question has come from Mr. Ramurthy. His question is: hardware failover is a default features or not?
Yeah, see, hardware, whatever feature we have explained, okay, all these are a default feature. Okay, so there is no additional module or a commercial involved. Only thing is we have to provide the two system. Okay, see, you want the failover, we have to provide two firewall system, and then we can map between these two systems. The high availability we configure. There is no additional cost involved in setting up the high availability. There is
Okay.
no, it is not a commercial module. Yeah.
Second, his question is: the logo will be OpenSense or astTECS? Because on the dashboard it is showing the OpenSense logo.
Yeah, see, as you know, we don't hide our, yeah, we don't hide, we are using an open source application. Okay, so since it is like we are into phase one of doing this R&D. Okay, so we are, if there is any modules we develop and then add it to this firewall, okay, surely we will bring a different UI for that. Okay, so until we make some effort or contribution towards the community, okay, so we may not change it, but still we are working on it. Once we make some contribution and then make changes uh, in the application, surely we'll make some changes. We'll bring astTECS into the branding, but still we'll keep the open source, open sense, because that's the application we are using it.
Yeah,
Okay.
I think I can also support Anna. I think from where day one we didn't believe in hiding the open source. At the end of the day, we are advocates of open source, and we truly believe that open source brings in benefits to the customer, and so there's no point in me telling that okay, that is almost like stealing to just put a brand. But as Dana has mentioned, when we do our own contributions, those parts we will surely market as
Okay. Thank you, sir. But before moving on to the next questions, I would request all the attendees, if you have any query, please type it on the chat box, or you can raise your hand, or you can just unmute yourself and ask the questions. The next question is from Mr. Praveen Kumar. It shows that the NIC is installed on the PBX box as well as OpenSense. Do you have any dedicated hardware in which install OpenSense?
Yeah, we do have dedicated hardware. Okay, so those hardware information we'll share it. Those means you will get those information from the sales team. Okay, so right now I don't have it, but we do have the dedicated hardware for this firewall.
Okay. Again, a next question has come from Mr. Ramurthy. Are we giving VPN clients?
Yes, you can see this VPN client. It's a open VPN client. Okay, so we can generate it and then you can share. There is no licensing or there is any commercial involved in this. Okay, so and using mobile. So if mobile supports the open VPN client, you can use it.
Okay. His next question is, are they applicable for both the desktop and the mobile? And does it work in all the operating system?
Yes, this OpenVPN is well known, and then it is used in most of the applications. Okay, so it will work on desktop, mobile also, and it's not all the mobile supports a OpenVPN client. If your mobile supports a VPN OpenVPN client, it will work fine.
Okay. His next question is there any limitation on the number of VPN clients?
No, there is no limit on the clients.
Okay. His next question is, will this work as a router, like a bandwidth balancing?
Yeah, we can do that. We can do the bandwidth balancing also with this.
Okay. I think all the questions from Mr. Ramurthy is being answered. Only one question he said that we want to see the reporting part.
I just wanted to mention on the VPN clients part. See,
Sir, sure.
basically from the software part, there won't be any limitations. But see, we are depending on the configuration what the customer wants, we will be supplying the hardware. So it's not that any hardware can support, say, 1 million VPN clients. So if the customer says, I want 10 VPN clients or 50, accordingly, we'll supply the hardware. So we will also be putting that this is a 10 VPN client machine, this is a 50 VPN client machine, because otherwise the hardware might not work.
Okay. Thank you, sir.
This is Ramurthy here. I
Yes,
have
sir.
some question there. Because my understanding from the price list is that products are with the hardware, bundled product. Am I correct, or
Yeah, that's
is
correct.
there understanding is different?
No, that is correct. It's a bundle product. So
Okay,
when
because
we tell,
somewhere it is software like installation, something has come, so that's why I. Okay, and another point is, see, most of the this mobile VPN, so that is very particular I am, because if you're saying some mobile work, some doesn't work, means it will not be very easy to handle with the customer. We have to be very clear what works, what doesn't work. We will not be able to tell what we cannot say and go to the customer, say some works, some doesn't work.
No, it is not like that. See, the firewall comes with the OpenVPN. Okay, so
Okay.
we provide a OpenVPN client. Okay, so if a mobile don't have, see, we don't know the who are the manufacturers support the OpenVPN. Okay, so if mobile supports the OpenVPN, it will work fine. Okay, if it has no support for
Okay.
OpenVPN, it will not
Okay.
work. So it is not that.
Apple phones will work.
No, I haven't used it. So.
Okay. So I need very
You can
clear
check
on
it.
that, because
Okay.
that is very
I think
important.
we will check
because our most of the customer will come with that kind of
Sure.
requirement.
We will provide a compatibility list.
Yeah.
We'll try to make a list as soon as possible.
Yeah, at least we need to tell that this will work, this doesn't work, because once we give the product, then we say no, this doesn't work, then it will be difficult.
Yeah, that's correct.
Okay, and I think Dhana, we have missed out the reporting part, which Mr. Ramurthy has requested on the reporting section.
Okay. I thought. Okay, so I can explain a little more about the report. See, from the report, we can see the current traffic through our firewall. Okay, so We can see it in a graph here. And
Can you share the page?
Just
It is not.
oh, sorry, 1 minute. See, is it visible now?
Yes.
Yeah. So now, see, in a report we can see the complete traffic of our firewall. Okay. See, this is the best part. We have the historical data available. Okay, so if we have the proprietary firewall, we may not be able to download, see the other than current data. Okay, so these information stored in system itself, so we can view all the data. Okay, we can even filter based on the traffic or the interface. This is our primary network, internet, and this is a secondary one. You can see the current flow. You can see it's 890 kb. It shows all these rules, whatever we have set. So individual routes, what is the bandwidth consumed by the routes it displays. So even here we have the VPN client. If they connect, you can see the user connection detail. Okay, this is about the health or the dashboard. Okay, so even we can get one. So this is a interface based output. So we can select. Okay, so now, sorry. Okay, so now I have selected the ACT internet connection. We can see the incoming traffic, 23 Mbps, 24, and this is the outgoing traffic, 28, 35. So the historical or the live data also we can see. In here, we can filter based on the IP address also. You can see now the traffic between the local IP and then internet. Okay, see now you can see a few more detail like this is a HTTPS connection to this IP address from this IP. The total usage was it is 255 MB, and the other one individually we can see, or even we can filter. So you can see now data used by this IP address, and whatever service he used HTTPS and HTTP, and then some other port he has accessed. So you can see the complete traffic about this particular user or this IP address. When we have option to export these information. Yeah, you can from the source destination IP and then service port protocol and then total packet used for this session. It's a session wise the data displays here. Yes, sir. Is there any queries on report?
Yeah, like if any something is somebody is coming like trying to enter our network like that, how do we check that? Is there any
See, no, it won't provide any pop-up alert, those things. Okay, so it is
okay?
just blocks it. When we check it in the log, we make it. But,
Oh,
so we may not have any log here.
okay,
So all the service has a log. Okay,
okay,
so using the log, we can. 1 minute. See, now we can see the firewall traffic. It goes
okay,
on. Okay, so if see, you can see default deny rule. You can see it is the denied. The,
okay,
these are the you can see denied rule in a different color. Okay, so these
okay,
are request comes from the internet.
okay,
Firewall is blocking those
okay,
requests.
okay,
So it won't give any alert or any separate report from the. It is not a report. It's a live table. Okay, so we can see it in the live.
okay. But for example, will there be a possibility of any compromise? Like even after having all these things, if something is gone wrong and like how do you identify
Yeah,
and how
see,
do
it is. Yeah, see, it is like now. See, what we do is we set a firewall and then we block the anonymous connection. Okay, but
okay,
still, if the user access any site, okay, assume I want to open a Pirate Bay and I want to download some file. Okay,
okay,
so it is a user opens it. Okay, so it is a it's a it's a valid request. Okay, valid request to the Pirate Bay. Okay, so that request firewall will not block. Okay, because it is initiated from the user. Okay, so now when I open a Pirate Bay, I can download any pirated application and then mostly it may contain the malware, and then I download and I install it. So now what happens is the firewall has no control, right? See,
okay,
firewall is we set a predefined rule and then we try to block the block the unauthenticated access. Okay, but if a user voluntarily he opens it and then he tries to download or he does it on his own. Okay, so there a firewall has no control, right?
okay,
So not see now we have so many service runs, even a browser itself, so many application you can run it, or you can have some service run on browser itself. Okay, so like you access those type of services or a site. Okay, and then you give access, or you it prompts it gives you it requests for some prompt and then you give some accept the request, and then they start taking your data or encrypt your system. Okay, so in that case the firewall has no control, right? If it's a user requested, user only accessing this service, so
okay.
firewall will
So
not block.
okay, so basically we need to like even outside traffic also we need to control from inside to outside also.
Yeah, that's what
Okay,
means
yeah,
For
so
inside,
it is yeah, that's a major thing. So
uh,
outside to inside it's not going to come. It is all our policy only will maintain. Okay, so whatever rule we are setting it from internet to internal network, whatever we set, only that will work. Okay, then with that it is not going to create any trouble. But only problem is from inside traffic to the outside, and then they give some application some uh, service, or they accept the term, or they install something, okay, on the desktop, and then it is a valid, means the user only requested, so firewall can't control it.
Okay, that is why you will be getting some you will be having a problem if something comes from, like, for example, I have seen some mails coming from astTECS.com, some spam mails.
Okay. Uh-huh.
So if you get
No.
into that, then it will be there is no control from a firewall,
Yeah, so
right?
firewall will not control those information. Even see, okay, see the spam mail. It has so many things. Okay, so now our salesperson, one of the salesperson starts sending a mail. Okay, so all the mail client, it is nowadays it is all the community. Okay, so all the exchange mail hosting applications, what they do is they share information uh, within them. Okay, so one of the salesperson starts sending 200 mail in 10 minutes. Okay, and then first our mail server will block the request, and to whom he is sent. Okay, this information will be recorded, and then maybe some time or 2 hours, 4 hours, 3 hours, this IP address means our IP address will be marked as a spamming address. Okay, so
Okay.
actually we are not actual spamming email ID, but one person did some 200 mail, 300 mail in one shot.
Okay.
Okay, and this is not a normal activity, right?
Okay.
So maybe he does he done it by mistake, but he has done it. Okay, so this traffic goes out, and then the people who checks this mail client. Okay, so this much traffic from this IP address looks like spam, so they will mark it. Okay, so that time, even sometimes our provider, mail provider itself will block all the request, means our mail will not work for some 10 minutes or 15 minutes, because
Okay.
it sends that something happening, someone trying to spam the mail, so provider itself will block it. Or sometimes this information passed with other service provider, so they mark our domain or IP address as a spam, so when you receive it, you'll receive it as a spam. So it is not
Okay.
only the one action it is happening, it has so many factors here.
Okay.